Miss Orton. I'm here today to show you the elephant toothpaste demonstration. You need to watch it and see why we call it that. We use this demonstration when we're teaching about chemicals called catalysts, which speed up chemical reactions. So in here, I've got some hydrogen peroxide solution. Hydrogen peroxide naturally breaks down into water and oxygen gas. At the moment, you probably can't really see much going on at all. That's because the reaction is really slow at room temperature and in natural conditions. So we are going to add, well, I'm going to add some washing up liquid, which is just going to catch some of the bubbles of oxygen gas for us. And again, it's now just looking like a green solution, not really much is going on at all. So today, the chemical we're going to try is called potassium iodide. It's a little bit like salt, but not, don't eat it. So I'm just going to add a load of this, and hopefully this is going to speed up our reaction. So you can see some steam coming off, that's the water vapour, and we've got oxygen coming out and collecting in the bubbles. And if we're lucky, we can even test for oxygen gas. So oxygen gas is given off in the reaction, and we can test for oxygen gas with what we call a glowing splint. So blow the splint out, and we try and relight the splint in the gas. So that proves that oxygen gas is given off when we can relight a glowing splint.
One of the experiments I really enjoy doing is to look at static electricity. So what we've got here is a Van de Graaff generator. Now this is a device that we use that builds up lots of static charge on the dome here, and one of the things we can do to show the effects of static electricity is to take these pie cups and we just sit those on top there. And in a moment I'm going to turn the electricity on. This band is going to start to whiz round and the electric charge is going to collect on here. And as that happens, charge will build up on each one of these pie cups. And because they're all having the same charge, they should repel each other. Okay, so let's hope, fingers crossed, this is going to work really well. So I'm just going to switch on and stand back. Something else that we can do with the Van de Graaff is we can investigate sparking. Okay, so when charge is built up on the dome, normally there's nowhere for that charge to go, so it just builds up there. But if we take this second sphere and we bring it close enough, then the voltage between the two spheres should be enough to produce a spark, and that's the static charge leaping off this across to this. So I'm just going to switch it on again, and then we'll see that happening, hopefully. Right, here we go.
Hello there, my name is Mr. Gould and I am going to show you a little demonstration called methane bubbles. We have in here some washing up liquid, and this is attached through this long pipe here to this gas tap. And out of this gas tap is going to flow some methane. It's the same as the gas that will flow into your hob at home where you're cooking your tea or boiling your pasta or whatever it is. So the methane flows through the bubble mix and we get this beautiful pile of bubbles. So we're going to collect some of our methane bubbles and we are going to react them with the oxygen in the air. To start the reaction, we need a little spark, and there we go. We get a beautiful combustion reaction. Now, if I am super duper careful, I can scoop up some of my methane bubbles and my glamorous assistant can light them. That was only a small pile of bubbles. what we'll have a go at now is a big pile of bubbles. So we've got our bubble pile grow and grow and grow. So speed it up, let's get it going. And obviously the bigger the pile of bubbles, the more fuel we have. So in theory, the bigger the combustion reaction is going to be. So I'm going to collect my pile of bubbles, getting bigger. And we'll have a few more. And I'm going to cut them off. And then, what I need from my glamorous assistant is she's going to light them in the middle.
Okay, hi, my name's Miss User, and today we're going to look at acid and alkalis and a reaction which is called neutralisation. In this burette I have some hydrochloric acid and some universal indicator, which changes colour when it's whether it's in an acid, alkali, or it's neutral. And hopefully when we add the alkali sodium carbonate into hydrochloric acid, we should get a rainbow effect, and hopefully, because it's a reaction, we can also see some fizzing. So I'm going to add it gradually. So as you can see, the acid is red, the alkali, which is sodium carbonate, is blue, which represents an alkali, and in the middle, where the acid and alkali are mixing, where there's neutralisation happening, we should be seeing it ranging from yellow to green, and then maybe possibly down here orange.
Hi, I'm Dr. Vidray, and I'm going to show you today how to do a heart dissection. Now, our heart is an organ in our body that pumps blood around our body. It takes it to our cells and then it needs to pump it all the way around, back to our heart, to our lungs to be reoxygenated, back to our heart again, where it then pumps it around the rest of the body. So there are two sides to a heart, and they work independently of each other, but they contract together. So the heart will pump 70 times a minute. It consists of 4 chambers. You have the atriums at the top, or atria as plural. We have a left atrium and the right atrium. And we have ventricles down the bottom, the left and right ventricles, and they're separated by a valve. And that valve is really important because it stops the blood from going back in the opposite direction. You want it to keep flowing the same way. Okay, so now I'm going to feel my heart to find out which side is the left ventricle, and that shows me which way round it is. Now, our left ventricle is what pumps it round to the body, which is a further distance than the right ventricle, which only pumps it to our lungs. So the muscle in the left ventricle wall is thicker. So when I look at my heart, I will feel it to see which is the thicker wall, and that's this one here. So this is my left side. Now you can see my left side is on my left here, but when I put it down, it's now on the right. So anytime you look at a textbook, you will see the left ventricle on the right hand side. Okay, so now I'm going to make an incision. There's 2 ways to dissect a heart. One of them you can do as a butterfly or a book, and opens up like this. But the problem with doing this way, you can see all the ventricles and the atria, but the problem with this is that you end up cutting through the veins and the arteries at the top. Another way of doing it is like this. Now with this one, all you're doing is cutting a V shape in the side, you're lifting it up, and then you can get your fingers in and you can feel the different chambers, we call them, the left ventricles, the right ventricles and the atria as well. And you can actually get your fingers and you can put them through the veins and the arteries like so. Now veins take blood back to our heart. So the pulmonary vein takes it from our lungs back to our heart, and the vena cava takes blood from the rest of our body back to the heart. And the arteries take it away from our heart. So the pulmonary artery takes blood from our heart to the lungs, and the aorta takes blood from our heart to the rest of our body. I'm going to do it in the V-shaped way because I think it's much more accurate and you can see and feel things much better. So what I'm going to do is just do a V shape on this side. So I get my scalpel in and I get through the side of that muscle until I can get my fingers in and lift it like I lift a flap in a book. So there you go. Oh, nearly there. Okay, that's it. Okay, so I've got my V shaped here. Now this is my left hand side, so I should be able to feel the left atria at the top, and we have the pulmonary vein that feeds into that left atria, and then I've got my ventricle down the bottom. So if I feel that, and there we have the aorta that takes it to the rest of the body. And then I can do the same thing on the opposite side. So this is the right side. So on the right side, if I lift that, see that, I can see the right atrium up here, which is fed into from the lungs via the pulmonary artery, and I've got the left ventricle down here, which feeds it via the pulmonary artery down to the through to the lungs. Now I've got a heart here, which I prepared earlier, a bit like Blue Peter. And I can feel that I have my thicker wall on this side, and I've pre-labelled it all up. So I've got my aorta here, which is the artery that takes it to the rest of the body. I have got my pulmonary vein, which takes the blood from the heart to the lungs, and then from the lungs back to the heart again via the pulmonary artery. And then the pulmonary artery goes into the heart, and then we have the aorta that pumps it to the rest of the body. The vena cava is the vein that takes the deoxygenated blood from the body and back to the heart again. And you can use a piece of string to show the circuit, the direction of the blood through the heart. And that is it. That is how you dissect a heart.